Done, sir.
Okay. Let's move on to question number 2. So we have to prove that 3 plus root 5 is an irrational number. Can you try this one exact same way?
First, we'll assume that 5 is a rational number.
Yes.
3 plus a root 5 is a rational number.
Yes. So this way, since it is rational, this will be equal to.
As they are rational, they will go into the P by Q form.
Yeah. Yes. So like this. 3 plus root 5 is equal to P by Q, where P and Q are integers. Okay, make sure you write that. P and Q are integers and Q not equal to 0. Very, very important. Okay. After this, look at this one. That some previous one was little that had multiplication. This has addition. So what will we do here? Take plus 3.
As we'll take plus 3 to the other side.
So what will happen then?
P upon 3Q.
No. There in the first one, 4 was in multiplication. Here I need to take plus 3 on the other side. So when you take plus 3 on the other side, what will happen? It is 3 plus root 5 is equal to P upon.
It will become minus 2.
Yes. So you'll have root 5 is equal to P upon Q minus 3. Now here what we'll do this side? We'll do
a cross multiplication.
Yes. So what will I get after cross multiplication?
P will remain P and 3 P upon 3Q.
No. Cross multiplication. P into 1, P. 3 into Q,
3Q.
3Q. So P minus 3Q upon Q into 1.
Q into 1, Q.
Q. So I'll get P minus root 5 is P minus 3Q upon Q. Did you understand this?
Yes, sir.
This calculation.
Yes, sir.
So we'll get root 5 is equal to P minus 3Q upon Q. Now, Q is an integer. P is an integer.
3Q is an integer.
Q is an integer. 3 is also an integer. And this Q again is an integer. So this becomes integer upon integer. So what is this then? Integer
this
upon
this is an integer.
So we have something upon something. So what does it become?
Rational.
Rational. Now the right hand side is rational, and that right hand side is equal to root 5. So if right hand side is rational, left hand side should also be rational. That means root 5 is a rational. But what do we know about root 5?
That it is irrational.
Irrational. So we are having a
contradiction.
So since we have a contradiction, what happens?
Our assumption was wrong, and root 5 is an irrational number.
So correct. So you got the idea, correct? How to do it?
Yes, sir.
Okay. Do you want to write it now? Unmute yourself.
I'll write it down.
Yeah, yes, better. You will understand also. So if you have doubts, ask me right away, okay? One more thing, this proof is called as method of contradiction. It's called as method of contradiction, or there is one more name for it, and it is also called as indirect proof or indirect proof. So in the exam, they can ask by method of contradiction or by indirect proof, show that so and so is an irrational number. So you should be familiar with these names.
Done, sir.
Okay. So we'll see question 3 now. Okay, before that, I hope you got the difference between here why 3 became minus 3 here and there in the previous sum why 4 went in the denominator.
Yes, sir.
There
Yes.
4 was in multiplication. That is why when it went on the other side, it became division. Here 3 is in addition here. Okay, that's why when 3 went on the other side, it became minus 3. Okay. Okay. Next is now represent the number root 5 and root 10 on the number line. You know how to show root 2 and root 3 on the number line, correct? Now, do you have your scale, pencil, and compass?
Yes, sir.
Okay. So, I'll show you root 5, how to show root 5 on the number line. Okay, so for this, we'll be requiring compass, a ruler, okay. First, show root 5 on the number line. First, we draw a number line. Okay. Can you do it along with me? Draw a number line. And one thing do, take little bigger distance, okay? So here 1, 2, 3, 4. Same thing here, minus 1, minus 2,
So I
minus
have to
3.
add more numbers, right?
No, not more numbers. By more bigger distance, I mean here between 0
in
and
the
1.
0.
Don't take 1 centimeter. Take 2 centimeters between 0 and 1. Do it, and once you're done, let me know with the number line. Will you draw the number line? Just draw the number line and don't do anything further.
Done, sir.
Okay. Now, before we actually start drawing, I want you to do, you have to think a little bit, okay? So I need to show which number has to be shown on the number line? Root of 5. Yeah. So that means if you draw a right angled triangle, okay, A, B, C. If you draw a right angled triangle, you have which is the hypotenuse here? Which side is the hypotenuse?
AC.
AC is the hypotenuse. So the hypotenuse should be of length root of 5. Correct? So whenever you have to draw, whenever you have to show a number on the number line, that like root 2, root 3, or root 5, you take the hypotenuse to be of that length. Okay, and AB, you take it to be 1. Okay, AB, you take it to be 1. Now, if hypotenuse is 5, this side is of length 1, what should be length of side CB? We can use Pythagoras theorem and find out. Yes or no? Let's use Pythagoras theorem. Can you tell me Pythagoras theorem?
AB square plus CB square equals AC square.
Let's substitute the values. AB is 1, so 1 square. CB I have to find out, so CB square. AC is root of 5, so root of 5 the whole square. This is 1 plus CB square. What is root of 5 the whole square?
Root of 5 is 25.
It's root of 5. Root of 5 whole square.
Oh, root of 5 would be 5, sir. Then 5 square.
No.
Okay.
Root of 5 the whole square is how much?
5. That's
yeah, 5. Now take plus 1 on the other side. What will happen?
Minus 1.
So 5 minus 1. How much is it?
4.
And then I had CB square is equal to 4. So CB will be equal to?
4.
Huh?
4.
No, you're forgetting the square.
4 square. 4 square.
Huh? 4 square? Pythagoras theorem we forgot how to use. I need to remove this square from here. So I'll have to take square root.
On the other square root. Then it will be 2, sir. 4
Yeah.
square.
I hope you are not confused at this step here. Yes or no?
I forgot a little bit. Yeah, but,
okay. Now remember, yes or no?
Yes, sir.
Okay, so CB is 2. That means this side is 2. Did you understand this?
Yes.
Now come to your number line. Now come to your number line. So what did we get, CB? We got 2. Okay, we got it 2. Now on your number line, at point 2, you start there. So I'll start here, point 2. So you name that as point A or whatever you want. Okay, name it as point A. I'll name it as point A. Okay, look here first pay attention here after this, right? Okay, now do you have your protractor with you? Yes? No?
No, sir.
You
I'll
don't have
remove it.
Okay, remove
I'll
it.
remove it.
Is it nearby?
Yes, sir.
Okay, remove it.
Okay, sir.
Okay, before we continue, can you just show me your number line? Okay, good.
So I've taken 2.5.
Okay, that's fine. Okay, now do along with me. Take your compass, take your protractor. Take your protractor and put the center of the protractor on point A, that is at 2. After that, mark 90 degrees. Mark 90 degrees. Did you do that? Okay, next. Take your protractor off and with the help of your scale, draw a straight line passing through that 90 degree. And put an arrow. So make a ray like this. Done?
Done, sir. Done.
Now take your compass. Take your compass, put the pointer of your compass on 0 and put the pencil point on 1. Okay, put the pointer on 0 and put the pencil on 1. Okay, just take the measurement. Okay, don't draw anything. Just take the measurement. Did you measure?
Done, sir.
Now, without changing the length, carefully take out the pointer and put it on point A. Okay, without changing the length, once you measured from 0 to 1, without changing the length, pick up the pointer and put it on point A and cut this ray. Cut this ray like this. Did you do up to here?
Doing, sir. Doing.
Yeah, do. Take your time. Take your time. Once you're done up to here, just show me, okay? Yes, perfect. Now, take your scale and join 0 up to that arc. take your scale and join from 0 up to that arc. And you can give it names also. This you can give 0 and this you can name it as P.
Done, sir.
Now take your compass, put the pointer of your compass on 0. And the pencil, take it up to this arc, that is up to point B. The pencil, up to this one. Yes, once you're done up to here, draw a bigger arc that will cut your number line.
Done, sir.
Now, this arc at which point it cuts your number line, that point will be root of 5.
I'll name it, sir. I'll name it.
Yes, and this you can check by Pythagoras theorem. We can check. Done? Look here now. How much was length of AB? How much did we take?
1.
1. We took it 1. And how much would be this length from 0 to 2? The length will be
2.
2. And this is 2, this is 1. By Pythagoras theorem, how much will be this OB?
Root
This
3.
is, no, see, look here now. This is 2, this is 1. By Pythagoras theorem, this
Root
is
5.
root 5. You can check it. Okay, I'll do the calculation and show you.
Oh yeah, square plus 2 square.
Yes. So look at the triangle. AB is one side, so AB square. OA is another side, so OA square. Hypotenuse is OB, so OB square. Okay. AB length is 1, so 1 square. OA length is 2, so 2 square is equal to OB square. So this becomes 1 plus 4 is equal to OB square. So this is 5 is equal to OB square. So how much will be OB? Unmute. No, I didn't hear you.
Root 5.
Root 5. So OB is root 5. And that only we had to show. And that is matching this. So did you understand right from the beginning what we did? Yes or no?
Yes, sir.
Okay, I'll go through it once again. Pay attention. We had to show root 5 on the number line. Okay, so before that, you do this rough work. You draw a right angle triangle, name it ABC. Put the hypotenuse as whatever you have to show. In this case, we had to show root 5. So write that length here. And this side, always you write 1 here. Okay, always. Always this has to be 1. Then you use Pythagoras theorem and find out this side. Okay, so by Pythagoras theorem, I got this side to be 2. Once you are done with this rough work and whatever length you have got here, in this case 2, come to your number line. And on 2, since at base we got 2, you start with 2. On 2, you name it as point A. Then you take your protractor. You take your protractor and put the protractor on point A and you mark a 90 degree. Once you have marked a 90 degree with the help of your scale, you draw a ray. After that, you take your compass. You take your compass and you measure from 0 to 1. Okay, you measure from 0 to 1. Then you put your pointer on point A and you draw an arc. You draw this arc. So from here, this will make us sure. This will surely tell us that AB is of length 1 because we are taking length 1 here. Okay, so AB, once you draw this arc, once you have drawn this arc, with the help of your scale, you join 0 to this arc here. you draw the straight line. You draw a straight line from 0 to this arc here. Once you have done that, you take your compass, put the pointer of your compass on point O, and the pencil you take up to the point B, that is up to that arc, and you cut the arc. Okay, you cut the arc up to it touches your number line. Okay, once it touches that point at which it touches the number line, that will be root of 5. Have you understood now? Now, given
Yes, sir.
any root number, will you able to show on the number line?
Yes, sir.
Okay. So these are just the steps. What I did there, if just written here. You have understood all the steps?
Yes, sir. Yes.
Okay. In the exact same way, for homework, can you do root 10 on, can you show root 10 on the number line?
Yes, sir.
Okay, so this is your homework showing root 10 on the number line. And tomorrow, before the class, 2 hours before the class, you send me a photo of this homework of yours. Okay, and also the previous sums that we did, that is the proof, practice both of them, write and practice. First we did 4 root 2, showing 4 root 2 is irrational. Second we did showing 3 plus root 5 as
Indirect
irrational.
proof.
Yes, the indirect proof, both I want you to write and practice. Okay, and I want a photo of this, your homework photo of root 10 on the number line. Okay, so we'll stop here. We'll stop here. Now, see you tomorrow, same timing.
Bye, sir.
Bye.